Hi guys, my name is Nikshu. In this presentation, I will be presenting on the merits of a controversial scientific concept, ocean fertilization. The order of our brief discussion goes as follows. We will first talk about one major problem faced by our environment in the present day, acidification. Then I will introduce phytoplanktons and explain the relevance to the proposed solution of dumping iron into our ocean. Lastly, we will highlight some of the more concerning issues with ocean fertilization to provide backing as to why this technique has yet to be implemented on a large scale. Let's begin. Now, take a moment to reflect on the last 24 hours of your day. How much CO2 did you produce? It is undeniable that every single one of us is contributing to the emission of carbon dioxide, whether through driving, cooking, or even just turning on the aircon. In 2019 alone, roughly 43 billion tons of CO2 were released into the atmosphere. One of Earth's natural mechanisms to reduce atmospheric CO2 levels is the absorption of carbon into the oceans. As demonstrated by this illustration, the dissolved CO2 interacts with water molecules to form a large reservoir of carbonic acid. Although this process removes carbon dioxide from the atmosphere, this in turn lowers the pH level of oceans and wreaks havoc on the marine food web. This image reveals the weakening and bleaching of coral reefs as a result of ocean acidification. Fortunately, the ocean is filled with an abundance of phytoplanktons. This autotrophic organism drifts in masses across the ocean depths and consumes carbon dioxide through photosynthesis. Let's take a look at this illustration. As carbon dioxide dissolves into the ocean, it gets consumed by phytoplanktons, which then sinks downwards and becomes trapped on the bottom seafloor. This effectively removes carbon from the atmosphere and counteracts the effects of carbon emissions. However, due to increased industrial and agricultural activities in recent decades, record amounts of carbon are dissolving into the oceans, and the current biomass of phytoplanktons are insufficient to reverse the effects of ocean acidification. In 1993, oceanographer John Martin first proposed a solution of fertilizing the ocean with iron. Scientists discovered that sprinkling iron dust in the right ocean waters could trigger plankton blooms the size of a small city. Together, the billions of phytoplanktons may absorb enough CO2 to reduce the concentration of carbonic acid in the oceans and cool the Earth's warming temperature. Laboratory experiments suggest that every ton of iron added to the ocean could remove 30,000 to 110,000 tons of carbon from the air. The proposed technique of iron fertilization is considered to be groundbreaking even to this day, as researchers have yet to discover other effective strategies to reduce carbon dioxide levels in the atmosphere. Although this may seem like a perfect solution, scientists have pinpointed some critical risks and inefficiencies in the iron fertilization model to explain why countries detrimented by the effects of acidification have yet to dump trucks loads of iron into the ocean. Opponents of iron dumping argue that a plan to increase phytoplankton biomass would not have a significant impact on carbon sequestration, as tiny zooplanktons known as grazers would eat up most of the phytoplankton population almost as quickly as blooms start. That way, much of the consumed carbon would quickly leak back into the atmosphere as CO2 gas. Phytoplankton sit at the base of the marine food chain, so interfering with their population would significantly impact marine ecosystems, particularly in the North Atlantic, where millions of people depend on fisheries for their livelihoods. Some experiments have shown that fertilization favors certain kinds of phytoplanktons over others, so the process could cause toxic algae blooms and deoxygenate water, depleting marine life. Lastly, scientists are concerned about the risk of offsetting the ocean's natural balance. Phytoplanktons have evolved the ability to produce organic molecules called ligands, which carry excess iron as they ride the currents to reach different oceans and feed populations there. Planktons have engineered the system to be optimal for themselves. That means adding iron to the southern ocean to stimulate plankton growth may reduce the amount of macronutrients being delivered to North Atlantic, which will lower the productivity of phytoplanktons there and ultimately achieve a net zero effect on overall carbon sequestration. CO2 emissions from human activities have exacerbated conditions of global warming and ocean acidification. So before a fail-proof solution can be discovered and implemented, we should all do our part to protect the health of our planet. Thank you very much.